Welcome to the project demonstration of underground cable fault identification system along with controlling also. So here we are going to measuring the underground cable fault identification with help of Arduino UNO, and also so-called status will be continuously displayed on this 16:2 LCD screen, and we are going to intimating the same status about the fault detection will be sent to the mobile phone by through ESP8266 Wi-Fi module. So here the power flow is we are going to provide the 230 volts input. In real time, this circuit will take the input of 220 volts from the each phase, and that will be converted into the DC in order to measure by our microcontroller, as it will work with maximum of 5 volts. And based on the short circuit happened between the line to line fault, then as we know that, so for example, let us consider from here to here 30 kilometers of cable, and this one is the 30 kilometers and 20 kilometers and 10 kilometers. Whenever the short circuit happened between 0 to 10 kilometers, so till this length means L, and as we know that the resistance is varies along with length of the wire, nothing but resistance is proportional to the length of the cable. So whenever the short circuit happened, the resistance will increase. Based on that, the voltage will be drops. So based on the drop voltage from the input voltage, Arduino UNO will estimate the distance. That estimated distance will be displayed here, and also it will display the which phase line to line is fault occurred. And also we are going to disconnect the power supply to the respective phase. So let us consider R, Y, B phases. So respective phases will be disconnected power supply in order to give the controlling system. And here that controlling will be done with help of electromagnetic relays. So here we are making use of 3 electromagnetic relays for 3 phases. So we are providing 230 volts input here as a single phase inputs, but in real time we can provide the 3 phase inputs. And this input 230 volts will be converted into 12 volts AC, and this 12 volts AC will be converted into 12 volts DC with help of this regulated power supply board. So after this we will get a constant regulated power supply of 12 volts, and that was given input to the power source input to the relays as well as to our Arduino UNO board. And these relays will allow this 230 volts, because parallelly we have connected the 230 volts to the these 3 loads through this electromagnetic relays. Whenever the particular relays got switched on, the respective bulb will get the 230 volts power supply. And right, so here from this Arduino UNO board we are going to distributing the 5 volts power supply throughout this LCD module as well as to our ESP8266 module. So coming to the interfacing connections, we have interfaced these electromagnetic relays at 10, 11, 12 pins of our UNO board here, and 8 and 9 pins of our ESP8266 module, and pin number 2 to pin number 7 LCD module, and A0, A1, A2 pins to this A0, A1, A2 pins for the respective phases to measure the input voltage. Coming to this regulated power supply, so there is a 4 diodes will act as a bridge rectifier, and after this capacitor we will get the pure DC voltage. And coming to this relay boards, on this relay board we can see the LEDs. So those LEDs will show us the status of the relay on off state, and these transistors, there we can see 3 transistors on 3 relay boards. This black color one, so this one is a transistor BC547. So here the switching flow is microcontroller. So Arduino UNO will trigger the transistor will trigger the relay and LED, and this relay will trigger the bulb. So this is the switching flow. So let me show you the demonstration. Before switching on this kit, we need to install the 2 applications. So one is network analyzer application in order to read the IP address of our kit, and another is Juice SSH. After installing these applications, change the hotspot name. So switch on the hotspot name and change the hotspot name to project 4956 without any space, without any capital letter, and the password should be 123456789. So after enabling these hotspots, then switch on the power supply to the kit. So once we provide the power supply to the kit, then we can see the one device will be connected in our phone, right? So we can see that the ESP device got connected. So now the all phases a normal condition. That's why the bulbs got switched on. So there are the two options. So in some phones we can see the IP address directly here. Otherwise, if you didn't get it here, then go to network analyzer application. So there we can see the go to options, do LAN scan and do the scan here. So there we get ESPress. So ESPress, it's going to be the 192.168.43.167. Note on this IP address. And now second application is Juice SSH. In this, go to manage connections, and here we need to add and then select type is telnet. Okay, and the IP address which we got from the network analyzer app .43.167. right, like this we need to enter, and the next third change is port number 8080. After that click on OK. So next time onwards you can directly see this when we open the connections. So now we can see that. So using volume up button we can increase the font size. Right. So now we can see that status is normal on or YB, and also same thing displayed on this LCD screen. Let me do a fault here. So this is 30 kilometers. As I said, this is going to be the RY faulted 30 kilometers. So single phase will be off as we isolate the power supply for the R phase. So same message on the Wi-Fi application also. So coming to the when it is normal, right? Again when it is back to normal, status normal, and here also normal. It's going to be the Y and B fault. It's going to be the B and R fault. Right. So this is the main useful function in underground cable faults. Why? Because if is there any underground cable faults detected, then instead of digging the throughout the length of the wire, so using this dropping voltage means we are going to checking the drop voltage based on the length of the wire. Whenever the short circuit happened, then the system will check the dropped voltage and it will provide us the estimated distance, so that is easy for the workers to dig at that particular point and they can repair the faults. Right. Thank you.